TalkShoe Live. This episode is being recorded and streamed live on TalkShoe.com. This episode is also being streamed to the following platforms: YouTube Live. You are joining the online studio. Your line is muted. You can unmute yourself by pressing *6 on your phone.
And I should be streaming live on YouTube. It looks like I am. If anyone is in the chat room and can type in that they can hear me okay, that would be great. My allergies are awful today, so you're just going to have to bear with me. But we're going to do a live Arctic sea ice update and a climate cast today. So it could be kind of a long show. So let me see how many I've got. I don't have anyone watching right now, but hopefully people will be coming in the near future. I didn't schedule this ahead of time, so people don't know that I'm here live on Saturday. I'm having to refresh my YouTube screen because it's buffering, but that's not stopping the live stream. It shows that I am live. And let me just check one thing real quick and then we'll get the show started. And if people come in late, they can watch the replay. Yeah, I don't have anyone watching right now, but hopefully some people will come in. So, good morning, Redwater. I see I do have someone here. Can you hear me okay? If you could just type into the chat there over on YouTube that you can hear me, that I'm coming through good, and that you can see a screen there where I've got the announcement page up. Great. You say yes. Great. Thank you for joining me today. I'm so pleased to be here. I've had a very busy week. I would have done an update. Thank you, Redwater. I'm glad you can hear me. I would have done an update sooner, but I've had a very busy week, and I've got some new things to show everyone today, and it's going to be stunning what you're going to see today. I've been stunned and just trying to understand how to read this Arctic sea ice on the NASA Worldview, and I feel like I've made a breakthrough. And so I'm going to share all that with you guys today. And after this session today, then tomorrow, Robin Westenra and I are going to do a live stream at 1 p.m. Pacific time, and we're going to be discussing my discoveries from today, and we're going to be looking at the Arctic sea ice together and doing a short discussion. It'll probably be about 30 minutes, and we're going to be like live reporters coming to you from the Arctic, and we're going to be showing you what's going on with this sea ice as we're continuing in this melt season. And we have a good 3 to 4 weeks left in this melt season. So I think anyone making an announcement that we're not going to have a blue ocean event this year is a premature announcement. I think we need to really watch this melt season and watch the weather and watch how things are breaking up. And this is my first year to be watching this and documenting it. And so we're making history here. This is a historical moment. And whether or not we have a blue ocean event, I think is not that consequential. We need to focus on the big picture and the fact that we are seeing the sea ice decline at phenomenal rates, at rates we haven't really seen before. And we haven't had people on the ground and showing this where you could see it, where we're seeing it and just bringing it to you. And we're all sharing in this journey together. So we're also seeing the effects of the declining sea ice. And so I'm looking at this as this is we're tracking, we're looking together, we're documenting this ice melt this season so that we can understand. And if we have another year, fine. And if we don't have another year, we need to get our spiritual houses in order because I think time is very short, very short. So let's get on with the show here. And I've got 4 watching in over on YouTube. And so I'm streaming live from TalkShoe. I'm not going to take any calls today. You can just type in the chat over on YouTube, and I'll be checking the chat periodically back and forth. So we're going to get started. And the first thing I want to go over, hang on, let me get everything set up here. Here is Climate Reanalyzer, the snow and sea ice cover from today. And we're going to look at great detail at what we're seeing here, but this is a good overview. And I'm going to just go back a few days so that we can see the changes in the last few days. Now, I did an update on Monday the 13th, and here's what Climate Reanalyzer looked like on the 13th. And we can see that there's a great thinning up here in this western part of the Arctic sea ice, and also it's breaking away from the Greenland coast up here, which you will see it continuing to do. And so here's the 14th, and it hasn't been that many days. It's only been 5 days. Now there was dramatic decrease from the 14th to the 15th. We can see that here, and we've had some storms up there. It's been raining up there and some snow, but there's been a system. And then there was a dramatic decrease going into Friday. You can see how much it decreased going into Friday, and then a dramatic decrease going into today. So you can see a whole area like this. It's basically collapsing on this western side all the way down. Now, we did see this hole open up in the Beaufort Sea last time. That's still there, and now it's collapsing to the right of that. It's quite thin, and when I show you this on NASA Worldview on the satellite images, you're going to be stunned. And you can also see how more of it has melted around the north part of Greenland. This has not happened like this in previous years. And you're also going to see that there's melting around these northern areas of Canada here. And so I think you're going to be quite amazed when we take a good look at this. Now I'll go ahead and zoom in so that you can just get an overview and get an idea of what we're going to be looking at. Because this is thin. This is, I mean, a polar bear can't sit on this ice and go fishing. Trust me. When you see these chunks like ice cubes in this area, you'll understand what I'm talking about. And it's not just this area, but the whole Arctic is in huge trouble. So to predict an ice-free Arctic at this point, I mean, to say we're not going to have a blue ocean event is totally premature, especially considering James Hansen's latest report that came out that said July was the 3rd warmest on record for the Arctic, and for this year. And then the the first 2 years where it was the warmest was 2016 and 2017. So for this July and last July and the July before that, they were the warmest years on record for the Arctic. So that's important. Here we have the Navy animated GIF, animated picture of the thinning of the Arctic sea ice, and it goes for 30 days and it goes 7 days in advance of where we are now. So I'm going to stop this. Okay, that's the 23rd. Let's go back to today. Here's today. And you can see holes forming in this very thin ice. And we can also see, I'm going to blow this up. It starts all over again when I start blowing it up. You can see the ice retreating from the northern part of Greenland, and we can see the melting of this old ice. This old ice is just going away. This is the multi-year ice. And when that goes, we're in huge trouble. And this is the most that's ever melted. And we can see huge thinning and retreat of the sea ice coming all the way around in the edges. So most of the sea ice is between 1 meter to half a meter or less. Most of the Arctic sea ice, what you'll see here. So there's the 21st. That's in the prediction period. There's the 19th. That's tomorrow. So here it is on the 18th today. And so I'm going to show you all of these areas, and I'm going to show you how this ice here, where you see it purple, it's broken up, and it's broken up over here and over here and over here. I'm going to show you all of this, and you will be stunned. You're going to be absolutely stunned. And I think you're going to walk away with a different perspective after this show today. I know that I have a different perspective, and I'm seeing that these ice melts go in seasons. It is the earth does make changes by seasons. It is a seasonal thing. And so it's not something that happens overnight. And so we'll see a retreat from one season, we'll see a huge retreat, and then it may not come back as much as before the next season. And then so we have less sea ice to start with, and then it melts more, retreats more. And so it's a huge season that involves years of this, but we are in the season of losing the Arctic sea ice from year to year to year. We are in the huge season of it, a multi-year season and a retreat. And as this happens, we're losing the habitat that's able to sustain life on the planet of all kinds. So I see that there will be massive beings leaving the planet, massive waves of beings. And I don't mean just humans by beings, I mean trees, plants, animals, sea life, and we're seeing that now. And so this is what we're going to be focusing on in campfire chats and in future videos as well as the meaning of all of this. So I did record precipitation. I'm starting to record that as well from Climate Reanalyzer so that we have an idea of what the weather was like, so that if it's raining in the Arctic, like we can see from this green area from Tuesday, then that's going to be melting that sea ice faster. So that's an area that we're going to be looking. And then on Wednesday, the system moved over to the left, and then it was raining in this straight line, and then it was snowing over here. This blue is snow. And then on Thursday, it moved over more to the west in a circular motion with the rain, and then the snow moved over. And then on Friday, it was still raining a little bit over there. And then today, Saturday, it's still raining, and we've got some more snow. And I'm not sure what this is, whether it's like what this gray stuff is. I don't really see that on the chart. So I don't know if that's open water. It could be open water because I am seeing open water over on the NASA Worldview. So we're going to leave that now. I'm going to change my screen sharing. I'm going to pop over to YouTube and see what's going on. Hi, Marcia. Thanks for joining me. I'm so happy that you're here today. This is we're making history. We're making history. This is the first time I'm aware that there are people actually tracking the sea ice and streaming it, and we're all able to see it together. So we're making history. So thank you for joining me on this journey here. So opening up that live chat to all the messages. Okay, now we're going to get into the next part of the report. I'm going to stop sharing that screen and pin me up there. When you see the green RE on the screen, that means we're recording. That's what that is. So now I'm going to share. I'm going to change and share my one of my web browsers. And so we're looking at Climate Reanalyzer. We're going to start with that. I'm going to pop over to YouTube and make sure that that has come on over. Okay, it looks like that has come on over. And now I'm going to pop back. We're going to start with 2-meter temperature. This is the average around the world today. We can see it's still very hot in lots of areas. I'm going to be mixing in the Arctic ice update with the climate cast, but we're going to spend a lot of time on the Arctic ice today. Now you can see some blue over here, which indicates the freezing temperature. That's average, but if you look at maximum, that's the maximum temperature. It's going to be up there today. There's less of the freezing, and most of the Arctic is above freezing, above zero, and especially at the North Pole. And this is real important because it's cracking up. I'm going to be showing you that it's cracking up there. So, and we can see Africa's very hot, and across the Middle East, it's very hot. And it's very, very hot across parts of the North America. South America's burning up. It's just not looking good. And for, I think it's just premature to make a judgment call on any of this. So then here's our 2-meter temperature anomaly, and we can see that Siberia is still above average, and also this Arctic Ocean, almost all of it is above average in the air temperature, and this is important, and especially over here in this East Siberia ice shelf. Now, when we hop over to CAMS, you're going to see lots of methane coming up all over in the Arctic, and it's gathering there. It's gathering, and so it's keeping that heat in. The heat is a nightmare up there. And methane is a nightmare all around the world right now. And you're going to see that. It's stunning. It's really stunning to be able to track all of this and see all of this. And so my main focus is to show people the data so that you can make up your own mind. You know, we're smart. We're not stupid. We can figure things out. We can see that red is bad. We can see that red is like shouldn't be there, especially when it's like in the red, like 20 degrees higher than it should be in the Antarctic this time of year in their winter season. We can see that. We don't need a climate scientist to come on and interpret that for us. We can see that that's bad. And so, I'm trying to teach the audience how to interpret this stuff and also how to discern and how to think for yourselves. This is important information, and you can think for yourself and you can figure this stuff out, and you can learn to trust that inner voice and your gut. You trust your gut instinct. If something doesn't feel right, it's not right, because that is your inner wisdom. Your subconscious mind is an unconscious mind is hooked into your autonomic nervous system, which is hooked into your gut, which is hooked into the God mind. And that's how we can know things. And the more sensitive you become, the more you can depend on that inner wisdom and that inner knowing. And that's what I help people do too. Here's our precipitation around the world. We can see it's raining on the west side in the Arctic, and it's raining on the east side over here. And there's no sea ice right here. There's sea ice over here, but it's showing that it's warmer temperatures if it's raining. So we'll just check out the rain around the world, and there are massive flooding. There's massive flooding going on around the world. On the East Coast, I mean, I had a client I was working with yesterday saying there's flooding in Pennsylvania. It's crazy. It's crazy. And I know that there's a lot of flooding in India, and there's earthquakes going off everywhere. There's a 6 point, I think it was a 6 point something in Costa Rica yesterday. There's more earthquakes in Alaska. We're not going to go over earthquakes. There are other people who track earthquakes. Look at this huge wave of water coming straight across the Pacific. That's a huge wave. I wonder if that's like an atmospheric atmos what's that called? I forget what I'm having a brain fart. uh, Atmospheric river. I wonder if that's what that is. And they're predicting another El Nino winter, the third one in what, 3 or 4 years. Pardon me for clearing my voice all the time. My allergies are killing me today. My eyes are killing me. My eyes are really irritated. It's not smoky here. The smoke has cleared out, thank God, but it's just all these after effects. Let's look at the jet stream. And the jet stream, we've got minor jet streams going around in the Arctic, and then it's making this loop in the Pacific and then coming down and around and around. So, you know, it's it's doing crazy stuff, making crazy weather, and we can see that the harvests are not what they were expecting because of all of the strange weather with the droughts and then the flooding and everything. And so I expect that we will start to see food shortages soon. This fall, we're going to start seeing food shortages, and we're in trouble. We're in big, big trouble. And I feel like the soul of the earth is just ready to go, the great one. That's what I call her. She's ready to check out and move on to a better reality, and we're going to be going with her. Sea surface temperatures. This is very important. We can see that the sea surface temperatures are above freezing and much warmer than that coming from the Atlantic and from the Pacific. And so as these warmer temperatures are coming into the Arctic, it's also warming the ice. And it's warming the ice is warming from underneath. I know that there have been some people reporting on that the ice is warming from underneath, but I'm going to show you how that is. I'm going to show you that today too. And then the sea surface temperature anomaly. This shows how much warmer the sea surface temperature is than it should be. And it's up in the red up here off the coast, all the coast of Siberia. Then up here in the Beaufort Sea, it's in the brown. Then all the way around this ice here, it's brown. And so, and we've got methane coming up out of these sediments and out of the bottom of the ocean. It's unbelievable what I'm seeing. It's seriously unbelievable. And when we look at cams, there's ozone, surface level ozone covering up this whole area of like Northern California and Nevada and this whole area. It's unbelievable. I'm telling you, we're in the end times, folks. We are in the end times. I truly believe that. And I don't think now's the time to let go and start and just party. I think we need to be aware. And we can see, and there have been articles recently about the water being so warm off the coast of Southern California that the sea life is dying. Well, it's right there. And up here in Baja, I've been showing that, and there's a lot of methane coming up there too. When we look at that, there's methane and surface level ozone there. We can see that it's much warmer off the coast of South America. That's also where methane is coming off. And then, of course, the Antarctic is still in their winter season. But the ozone hole is growing over the Antarctic. So, and we also have surface level ozone appearing in the Antarctic, which I don't understand. I still don't understand that. So we're going to leave Climate Reanalyzer, and I'm going to hop over to a recent blog that Robin Westenra put up on his post. He put it up, well, it posted today, but it's called Further Analysis of the Arctic Ice Melt, and he dated it yesterday. And I'm going to be going over this area that he's talking about, that he analyzed in detail, and we're going to be talking about some of this tomorrow, live streaming too. So, but I'm going to show you a lot more on the Arctic as well. He says, we were never going to see a blue ocean event in the sense people commonly think of it, but the deterioration of the sea ice is epic and unacknowledged. I feel that when things start to look like this over much of the central Arctic plateau, we can start to talk about a blue ocean event, enough possibly to trigger some of the things Guy McPherson is fearful of. And his headline is The Disappearance of the Ice at 80 Degrees North. And here's a close-up of that broken up sea ice at 80 degrees north. He says there's been a lot of talk in the past 48 hours of there being no blue sea event, something that is left undefined in social media comments. However, the deterioration of the ice is epic and continues with perhaps another 3 weeks or a month of melt left. I've decided to look at just one position, 80 degrees north and minus 156 longitude, and that's west, 156 west, for comparison. I do not know what the distances are, but it is getting very close to the pole. It is approximately the same latitude as the northernmost tip of Greenland. You can just make out the area in the photo of the Arctic on the left-hand margin of the central Arctic plateau. And it's this area that he's focusing on, this area right up here. At the beginning of July, um, July the 2nd, you can see the area is still frozen. That's where he zoomed in. By July the 10th, it's just starting to open up, and so you can see it cracking and opening up. And the 27th of July, and you can see it's pretty much turned to mush here. And we're having to look through some cloud cover. He says cloud has been covering the area the bulk of the time. And it has, because it's very cloudy up there. There is almost constant clouds, and they move around. And that's one reason it's hard to analyze the sea ice, because the cloud cover can be quite thick, and then it moves from day to day, and so you have to read through what you can, and then you have to compare from one day to the next, and so you really have to like be a sleuth, and like be almost like a private investigator, and look behind the scenes and connect the dots where you can. He says, but when the cloud lifts, you can get a clear idea of the extent of the melt. I would estimate that it's covering many hundreds of kilometers. This photo is from the 13th of August, which was the day I did my update. And zooming in, we can see more clearly. And you can see large areas of the blue ocean there. That is the clearest view we have, because since then it's been largely under cloud, and this is the latest photo we have. And you can see there's cloud covering it, but you can see through the cloud that there's blue water there. And he says, meanwhile, it looks as if the area is cooling down a little, with about half the area being at freezing. And these are average figures. That's from yesterday. And that's the end of his blog. And Guy McPherson commented on that blog post and said something like, great work, and that the Arctic sea ice is a huge mess, or something like that. And we'll be talking about that tomorrow as well. Now, before we go over to NASA Worldview, I'm going to hit a couple of other websites, and then we're going to spend the rest of the time on NASA Worldview. We're going to go next to the National Snow and Ice Data Center from the Arctic Sea Ice News and Analysis. And of course, they're a day later, or they're day behind on their data. This is the sea ice extent, and this really includes any little thin part of ice. I mean, it could just be a little thin covering like frost, and they count it as sea ice. So it looks pretty good from that picture. Here it is in concentration though, and we can see that this darker blue is much less concentrated, and it's broken up. It's all broken up. Where you see blue, and even where you're seeing white, it's breaking up. Here's their chart, and it's showing that we're not as headed down, straight down in a nosedive, and so the sea ice extent, at least, is looking better than 2012, but it's still not good. So we don't want to get a false feeling of security. Here's the Antarctic. And we can see it's still growing. It's a little bit outside the lines on this west side, but I wouldn't say it's phenomenal in growth. And I wouldn't say that their concentration is very good. And we saw that the temperatures are too warm down there. And some other climate scientists have been reporting that the glaciers are in trouble down there, and because it's too warm. And when it hits their summertime, they're going to be in big trouble, big trouble. So, and we can see that the sea ice extent down in the Antarctic is at a low. It's it's right level with 2017, which was at a low. So that's not looking great. So there's that one. And now here's the Navy website that I took the, this is our thickness from today. And we can see it just looks spidery, like a spider's web. It's quite disturbing to see that. So, and we can look more at this later if we want to. Now, what you've all been waiting for is the NASA worldview. And my big find, well, first of all, we're going to look at it without this, some of these extra layers. This is from NASA. This is satellite imagery of the North Pole as seen from outer space. Here it is from yesterday. Here's what they have from today. They don't get all of their data in until it comes in at different periods during the day. We do have data in from today from all of the North Pole except for this section here over Canada and parts of Greenland. And this is the area that Robin was speaking of, this 80 north and 156. And we can, the longitude and latitude show up here. And so here's one. It's this area that is well, basically this whole area in here. And we can zoom in, we can see that today there's basically no cloud cover looking at this. And so we're getting a very clear picture. Now here we're heading into cloud cover where it starts getting fuzzy. But we've got a very clear image of the sea ice in this area. And there's some cloud there where it gets a little fuzzy. So this is all from today. And so when I zoom in the closest, we can see that this sea ice has really lost a lot of integrity, a lot of integrity. And what looks like solid ice is not. Like I said, a polar bear cannot sit on that ice and go fishing. And so this is quite thin, and it's still melting. Here's a huge hole right here. This is well within the 80-degree north latitude. That's this line all the way around is 80 degrees north latitude, and it's melted way in on the right. It's way in. It's right here on this right-hand side and coming down. And so let's hop back to where we can have the full view. Now, my big find that I'm going to share with everyone is we can add layers that can be very helpful in helping us understand this data and helping to interpret it and helping to see the difference between the cloud cover and the ice. I'm sorry, I'm hitting the microphone. And so this is going to be a great tool in interpreting the sea ice and interpreting where we're at with the sea ice. And what we do, we click on the arrow down and we go to add layers. And here are all these different layers that you can add. And the layer I want to add is ice surface temperature. So I'm going to click on that and close that. And we can see these colors coming up. And we can see all this green area coming up. And when I put my cursor over the green, okay, here's the chart for this ice surface temperature day. And the little eye is showing. And if you want to hide this layer, you just click on it and it hides it. Kind of like Photoshop where you have layers that you can look at and take away. But if you want to see the layer, you click on it again so that the eye can, so that there's no line over it. And this is showing the sea ice temperature. Now, what I read in this modeling is that they can't measure the sea ice if there's cloud cover. So what you're seeing is where there is not cloud cover, we're seeing these colors of green and blue and kind of this chartreuse color and the yellow. And then when you put your pointer on that, then over here, it'll show up the temperature in Kelvin degrees. So like for instance, I put my pointer over here on this yellow area and it shows at 281.7 degrees Kelvin, which is above freezing. And so I didn't know how to read Kelvin, so I had to do a bunch of research and find that out. And so here's a cheat sheet for Kelvin on how to convert Kelvin. But so it's red in minus. And then when you get to zero degrees Celsius is 273.15 degrees Kelvin. And that's the freezing or melting point of water. That's fresh water. That's not seawater. Seawater freezes at a lower level. We're going to go over that in a minute. That's real important to understand. So so we're going to be going back and forth between a couple of different charts here. So see this area where it says 281.7 degrees Kelvin, that's above freezing. And that's quite a bit above freezing. Okay. Now, when you move your arrow over to this green one and it says 270.6 degrees Kelvin, that's just below freezing. But I found this paper, this scientific paper, to help me understand how to read sea surface temperature. And this is off of the nasa.gov website. So I will leave the link below. This is a PDF file that people can download, and I recommend you downloading it and reading it and learning what all this means. And it talks all about this model of measuring sea ice temperature. And it's a whole science they've developed and how to measure and tell the difference between the salt saltwater ice and the freshwater ice and all this stuff because it freezes at different temperatures, and they have different ways of doing it all, and it's all very complicated, and so they have scientists who specialize in all this stuff. But here is where it's explaining it, and it says all okay, ice extent because any pixel that has a temperature of less than 271.5 Kelvin is considered to be ice, and any pixel with a temperature of 271.5 Kelvin or greater is considered to be open water. So that's lower than the freezing point of fresh water. And it says because sea ice is saline, it freezes at a temperature that is less than 273.15 Kelvin, the freezing point of fresh water. So we use 271.5 Kelvin as the cutoff temperature between water and ice for the cold period images in the Arctic Basin, although a user can select their own cutoff temperature based on the ice surface temperature to develop a sea ice extent map. During the warm period in the summer months, melting snow and melt ponds, and they show it here, but it's just a different color grid, will likely have temperatures nearer that of melting freshwater ice because meltwater on the surface of multi-year flows is less saline than water on top of the first-year flows, since salts are ejected when an ice flow survives long enough to become a multi-year flow. So what they're saying is when we get into this multi-year ice down here, that's thicker, that's near off the coast of Canada and in these areas, little nooks and crannies in these between these little islands and to the north of Greenland, then this is more fresh water because it's a melting refreeze, melting refreeze, melting refreeze. But these other like the thinner areas of ice is more of a single year freeze. And so it's going to be melting at a lower temperature because there's more salt water involved. And we can also hop back over to this Navy website and it can tell us SSS is sea surface salinity. And so where it's red is more saline or more salt water, where it's red. And so as it moves from red down through yellow and green and then into the blue, that's more fresh water. So you can see it right there. So you can see as this ocean water from the Atlantic comes in, and not as much, but also from the Pacific, it's mixing with this more fresh water and causing it to be more salty and more saline. And so it's going to be melting at that lower temperature as well. So there's that. And we can also see how that's been mixing over the last 30 days. And it's hard to tell, but it is. Things are happening there. And you have to remember that it is starting to cool off a little bit up there. It's still daylight, They're still having full sun up there, but it's not at a straight overhead position because the North Pole has started to tilt away from the sun. And so it's experiencing some cooler weather, but it's still melting. And it's also melting from underneath. And I'm going to be showing that as well. So how we're going to use this tool of this ice surface temperature is to show us where the clouds are and where they are not. Because this is, as I said, it reads this ice surface temperature where there are no clouds. So like this is clouds. Down here is cloudy. So we know we're not going to be able to get a good reading of the sea ice through the clouds. So what we can look at or focus on is we can get this area that's like all this green where we know it's measured, and then we'll hide that layer. And so it's basically outlining this area. And you can see a demarcation in the ice. And I was telling Robin I was basically learning how to read the sea ice, and it looks more flat where there are not clouds. And so we can start zooming in here, and we can see this whole area is cracked. It's lost all kinds of integrity. Now, Robin was Robin was looking at, let's see where he was looking, at this area. But we can see it's it's not just this area, but it's this whole huge area. And I expect this whole huge area to be going. Wait, let me get my. Okay, so this is in clouds, and we can assume that the rest of this area looks pretty much like this, the green. We can just assume that. So, and you can see like these lines, these are huge cracks in the sea ice, folks. This is cracks in the ice. And when we zoom in, that's as close as I can go, we can see the water. That's water. That's water. That's water. That's water. And this is at 83 degrees north and 165 degrees west. And we can see the cracks, huge cracks forming. So let's turn this layer back on. So, I encourage people to come and look at this yourself. You'll be amazed. You'll be amazed, and you'll be witnessing Mother Earth going through these changes yourself. Look at this huge crack right here. That's new. That's all new. This is not looking through clouds, folks. This is the sea ice. It's all the way down through here. And then there's clouds, but we can assume that it continues. We can assume that. There you go. I hope you understand the magnitude of all of this. Here's another patch where it's not looking through clouds, and we're just going to zoom in, and we can see the huge cracks forming. Look at this. There's a huge crack. And so in the next, and this is at 87 degrees north latitude. Here's a patch. You can almost see right through the ice there. Okay. Can see, almost see right through. I'm zoomed in as far as I can go, but you get the idea. I hope you understand the magnitude of this. Look at this. Look at this. And I didn't understand before really what I was looking at. And I didn't understand how to discern between the clouds and the ice. But this is a huge tool. So let's look down here now above Greenland. This is ice. Look at that. Look how far up that has broken off. It's a huge area. And actually we're moving into clouds here. So I'm going to look at some other days as well, and I'll show you how we can look at other days too and put this picture together about how widespread this breaking up the ice is. So for instance, if I go back to the 16th, here's an area where we will be able to see through the clouds with the breaking up of the ice here. You can see it. Look at that. There it is. This is the thick ice, the thicker ice that's melting. So this is one reason it's taken me a couple of extra days to get a report together, because I have been studying this. I've been spending hours and hours looking at the sea ice and trying to figure out how to read it and how to interpret it and just meditating on it and coming up with all of this. We can see that's sea ice, and that's at 272 Kelvin. So that's right below, that's above freezing for salt water. And it's almost right at freezing for fresh water. So the ice is melting from underneath because we're seeing it breaking up. If it weren't melting from underneath, we wouldn't see cracks. We wouldn't see it deteriorating like this. It's melting from under the surface. So there might be volcanoes going off. There are earthquakes. We saw there are earthquakes, which means there is geologic activity going on. We know methane is coming up. Here's another area that's losing a lot of ice. Now there's cloud cover, so we can't really see it very good there. Okay, here's today. Let's look at it today. It's hard to see. It's still kind of hard to, I mean, that's from yesterday. It's still kind of hard to see, but we can see it's broken up. So let's go back to a day where it's more visible. Here we go. Here's a good day to look at the sea ice. Look at that. There you go. That's what it looks like. That's zoomed in all the way. This is that thick ice, folks. That's that multi-year ice. Then there's some clouds. Wanted to show you something else that flipped me out. Look at this, right up to the North Pole. This is from the 14th. Let's see what we can see as far as cracks. Now this means there are no clouds in this. So here there are clouds, so we're not going to look there because we won't get a good reading on that. But let's look right there. Let's zoom in on that. So that's these dark areas. See these dark areas? Let's zoom in here and see what we can see. Okay, it kind of gets distorted, but that looks like we're looking through a thin layer of ice down to the ocean, and the same here. And there's the North Pole right there. Okay, let's see if we can see through here. It's a little distorted, but we can definitely see through here. Okay, there you go. We're in trouble. That's all I can say. I know I keep repeating myself, but I was I was literally without words when I really started looking at this and understanding it. Let's look at this one to see that whole, I mean, this, and that's from the 14th. There's clouds. And see, the clouds keep moving. So you have to look at it where there are not clouds breaking up. You can see the cracks. Look at that. There's ice. There's ice. There's no clouds right there. Let's look at that. Right next to the North Pole. It's hard to tell, but it looks like that's like just a skim of ice there and very thin ice. So these are the things we're going to be monitoring in the next weeks. And Robin and I, at this point, we had plans to be doing these live streaming things where we come on together and like I'll be screen sharing. We'll be doing it on TalkShoe and streaming over to YouTube. And we're going to be talking back and forth, and he'll say, go here, go there, and let's compare this date and that date. And so it's like two researchers coming together, and you can hear us brainstorm together. And so look at this. Yeah, it's cracking. It's cracked up. And this is at 85. There was one that really flipped me out. Um, Let me see if I can find it. There's just so much to show. Um, okay. Um, this was from when I did my, wait, let me double check something. Look at here on the 11th. Look at how much ice was visible on the 11th. Huge area. You can see where it looks flat there. That's ice. And then the clouds come in and look like mountains and stuff. But you can see the huge cracks. You see that? Huge cracks. Where the ice is losing its integrity. You can see that right there. Still trying to find that one that was really close to North Pole. And it was so Just kind of blew me away. Here's from the 16th. See what we can see from the 16th. Oh, right in here. See, that's water right down in there. There's probably a thin layer of ice there. That's ice. There. It's not clouds. We can zoom in. For the longest time, I thought that was shadows, but it's not. That's ice, and then that's cloud. So you understand how this tool is going to help us? And I found another thing, another layer that was really interesting if you want to really flip out. So we've got that one turned on. And I find I have to turn that one on every time when I come. Otherwise, I can't get an accurate reading on the temperature. It won't read it. Nuclear power plants. We're going to turn this layer on. Now, this is the nuclear power plants layer indicates the location of nuclear power plants across the world. It is part of the population exposure evidence estimates in proximity to nuclear power plants database version 1. So I just turned on that layer, and what you're going to see, we're going to hop up here. You see, we've got one right there. That's a nuclear power plant. They show up as red dots. You see where that is? That's off the East Siberia ice shelf. Yep, it's right there. We're looking through a bunch of clouds there. Here we go. Right there. Nuclear power plant. I don't know the name of it. I haven't gotten that deep. But that's right there. And the sea surface or ice surface temperature here in this like golden color is 284.6 degrees Kelvin. Oh, well, 294 is 21 degrees Celsius. 284. Okay, let's see. 284 Kelvin is 10.85 degrees Celsius. So there you go. I lost it. It's a little red dot, but what you're going to be able to see, oh, there it is. We can also use this as we look around the world. If we want to look at sea surface temperatures and how hot it is, like all of these red dots are nuclear power plants. Like here we go with Norway and Sweden and Finland, where we saw articles where nuclear power plants were being shut down because the water was too warm to cool them. Here's one right on the coast there. There's a whole bunch right up in there. Here's more if you're down here in Russia. But it's around the world. And if you click on geographic, you can see them all around the world too. I'm going to turn off the ocean temperature. So that's just another way you can use NASA Worldview. And I think that database only goes back to 2012 or 2014. Oh, 2012. Here it is, 1956 to 2012. So it doesn't have the last 6 years of nuclear power plants, but you can just assume that there's more. But these are all that are on the map. They all have to be babysat. They all have to be cooled, even if they've been decommissioned. So I'm ready to go over to CAMS. But before I do that, I'm going to hop over to YouTube and see what's going on. Let's see, I've got 39 watching. Oh, thank you, Redwater. You say good find, Margo. Putin is opening up the waterway. Well, not just Putin, it's the US. It's a whole group. I did a whole video on it. I'm just scrolling back through some of the comments. Hi, Angel's View. Thank you for joining me. Hello, Les Winter. Thank you for joining me today. There's Marcia. Yeah, more cancer. Yeah. Hello, David Alcock. Here's a shout out to you. Anyway, it looks like a couple of people are doing most of the commenting. Shout out to Sony Mini. A shout out to Patricia Powell. Yeah, it looks very bad. I don't know if we're going to go another year, I mean, I'm just taking it day by day. Shout out to Omega Man. Thanks for being here. Shout out to Gordon Russell. Thanks for being here. I think that's most everybody. Sultan Bev. Welcome. Shout out to you. Yeah, I didn't announce it, but tomorrow we're going to be live streaming at 1 p.m. Pacific time, Robin and I, just for about 30 minutes, just to look at the Arctic sea ice. Okay, now we're going to hop over to CAMS. Let me get a drink of my tea, and we'll finish up this climate cast. I don't even know how long I've been going. Hey, Cheryl Ann. Oh, you're too shy to comment. No, thank you for being here, and thanks for watching my work. Don't be shy. You know, we're all here together on this journey. Shout out to however you say your name, Adarukia in Hexalian. Shout out to Cliff Kirkton. Thanks for being here. Yes, the situation changes day by day, or Adarukian, Rukia, however you say your name. Les M, shout out. Well, I know Guy said that the sea ice won't go away, but I think he um, is going to change his perspective after he gets a good look at this. I'm not sure that he was aware of some of the data. You know, he is limited on doing research, and he's really not doing research right now. He's in Belize, and when he comes to the States, he's busy traveling and giving talks and stuff like that. And from what I understand, he he's not doing research, and he has limited internet access in Belize, and so I don't know that he is up on all the latest. All I'm doing is reporting what I see. And it's not important. What's more important is we're seeing an epic ice melt here in the Arctic. Hey, Gray Silverback, shout out to you. Thank you for joining me. Glad you're enjoying the update. What and I think we're too focused on saying, oh, well, this year is going to be the Blue Ocean event. And if we don't have it, then, we're going to be okay. But, the melt season isn't over. And just because someone doesn't interpret it as a Blue Ocean event doesn't mean anything. We're in big trouble. We're in big trouble. And we can see that the Arctic sea ice is melting, and it's not, the polar bears can't go out there and sit on a big sheet of ice and fish. They just can't. I'm sorry. It's breaking up, and we're going to be documenting it. Robin and I are going to be reporting like live reporters from the North Pole on a very often basis, every 2 or 3 days. That's right, Atarukia. It only takes a powerful enough Arctic cyclone to change everything for the worse. So that's right, Angel's View. When it goes ice free, it doesn't matter because we all know it's underway, and that's plenty. And I see it as a season that years. It's like it's a huge cycle. It's not just one tiny season in a year. It's the cycles. I mean, when you look from the cosmic viewpoint, I mean, we go in thousands of year cycles. And so for us to just, say, well, it's going to be this certain date and this certain year, I think is, kind of short sighted of us. So, okay, let's move on over to cams now. Let's see if it switched over on my live stream. I may have to change my screen share. Yeah, I'm going to have to change my screen share. So hang on. I've got to change my screen share. All right, now we're going to look at cams and we'll wrap up this update. Okay, it's up now. This is Copernicus Atmosphere Monitoring Services. This is out of the EU. I use this all the time. And we have methane data for 3 days, Tuesday, Wednesday, Thursday. They're usually a few days late accumulating all their data and getting it in their database. And so once it goes past the 16th, it's into the forecast time period. So we're looking down on the North Pole, and you know how to read this. And I'm not going to go over a whole bunch about how to read it, but the charts down here, this is in parts per billion. We're in big trouble, especially with methane. And these greens are in the 1800s, and then when it hits the yellow green, it's 1920. Then this brick red is 2000. Here's 220 or 2020, then 2040, and then it says 75,600 on that black area. You know, I'm just the messenger. I don't know if that's right or not, but it's high. And, you know, now they're finding that methane is being released more places, and, you know, more melting permafrost releases more methane than they thought. And it's coming up from the riverbeds, it's coming up from the deltas, hell, it's coming up from everywhere. What can I say? Now we can see large areas of methane coming up all around from this eastern side of the Arctic Ocean, and it's actually gathering up in the upper atmosphere. And I can show you that as well in a minute. And it's quite disturbing to see this red just moving across. Now, what this means is it's this is surface level. This is being released from the surface. So it's being released from the sediments in the ocean where it's melted, and through the ice that's melting and off the shores and um, around here. And then it's being released on all these different continents, you know, with industrial civilization and stuff. And it's just blobs of black. And every time that I do these updates, it's like, I haven't ever seen it this bad. It's like it's even worse than last time over here for India and China and Asia. It's unbelievable to me. I mean, it just blows my mind to just see this. So I'm going to change this view now to Arctic. That was on North Pole and it had a broader view. This is going to be a more close in view so that we can get more details on what's going on with this methane. And you can see it popping up right here by Novaya Zemlya and popping up all over here. Here's the East Siberia ice shelf, and that nuclear power plant is right over here somewhere. So, you know, it's nothing good can come from all that. That's all I can say. So we're going to load that movie. I'm going to pop over to the chat and see what's going on. Throwing out pizza crust. I don't eat pizza anymore, Les. Dams are methane emitters. Yeah. All the dead stuff that gets caught up in there. Yeah, that makes sense. You know, I'm cutting down on my food intake. I'm only eating one meal a day, and the rest of the time I drink juice or tea or some kind of liquid. And I'm going to even be cutting down on that. And I haven't been talking about this. You know, it's kind of like way far out there. But for many years, I have been reading and researching and studying breatharianism. And that's living on light, living on the divine energy. And, you know, not taking in food. And there are people who can do it. There are people who do it. And it's a process, and it takes years for your body to adapt and to be able to do that. But, that may be one way that we could, you know, sustain for those who are able to make that transition while we're in this transition period with the earth. It might be an option until the very end. But I just don't know how toxic the environment is going to get to where we're even going to be able to get prana, really get the divine force in without it being, all messed up with all the toxins and stuff. I mean, frankly, I'm ready to go. I'm not trying to prolong my physical body here. I just want to be in better health. And, I'm not in good health right now. It's nothing the doctors can diagnose, but, I'm just unwinding. And it's no fun unwinding. Okay, so watch this methane coming up when it coming up here in this in Laptev Sea and the Kara and Barents Sea, and then over here in the East Siberia Sea. It's black, folks. It is black. That's awful. I've never seen it. And look at it here. I've never seen it like that. Seriously. Now, how can you say that the sea ice is not melting and you've got all that methane coming up? Seriously. It just makes me sick. I've never seen that before. Waves and waves of that red and black. Now, let's look at a different level. Let's look at when you go total column, that's where the methane goes all the way up through the layers. Now, it's very high in total column over here in China and Asia, but let's see how it's gathering over the Arctic. At what level? We can see it's gathering at 850 HPA. And so as you go higher in the atmosphere, it's lower in the hectopascal Pascal readings. So it's gathering there. It's gathering at 500 HPA. You can see that. I'm not going to run a movie for all these. You can do that on your own. It's gathering at, what was this, 300 HPA. So as it's moving up in the layers in the atmosphere, it's not dissipating. It's still being held in and gathering. And then this is at 50 HPA at the highest level. So that's, that's lower, but that's a very thin level. So let's go back to total column. Now, I'm not through with methane. We're going to do the world view over here. And this defaults, when we go into the plots view, it defaults to total column. And so I want to see it at surface level. And I'm going to go back to the beginning of our time frame here. And I'm going to widen my screen so that we can see the whole world now. And we're going to run this movie. And you can find your neck of the woods and see what the methane level is where you live. There it goes. I'm seeing a lot more green down here in the South Atlantic off the coast of South America. A lot more green methane there. It's also being released from the Antarctic. You can see it coming off the um, West Peninsula, Northwest Peninsula of the Antarctic, or Western Peninsula, that's what it's called, in the green level. Are there any areas you guys want me to zoom in on that? I'm going to check back over in the chat and see. Oh, red water. The way China can emit so much methane is because it's so densely populated, and they have high industrial civilization. They're still burning a lot of dirty coal, and they grow a lot of rice, and it's a lot of humid areas, and with such a densely populated area, that's why. It's from humans being there. Yeah, China has lots of coal burning. They haven't upgraded to the cleaner coal like the Western civilization has, Western areas. Hey, tree hugger, shout out to you. Okay, methane is definitely not looking good. Okay, I'm gonna pause that, and now let's hop over to ozone on our next part of the report. I like looking at, well, let's do sulfur dioxide next, because sulfur dioxide levels affect the ozone levels. Let's see how far back we have reading on sulfur dioxide. It's current through today because they're on UTC time, so it's back from Tuesday through today. So let's get it over here on our flat view. And wherever we see high sulfur dioxide levels, we're going to see a thinning of the ozone as well. This defaults to total column on our sulfur dioxide readings. And this is read in parts per million. And we're going to load this movie up and let this run. What we're seeing is the overall sulfur dioxide level is rising around the world. The base level is rising to like this zero 0.5 parts per million to 1 parts per million, and even higher when it gets into the cream color, that's 2 parts per million, and so forth. And then like this orangey red and the red, and then the dark red usually indicates geologic activity or volcanic activity. It can also be from wildfires that are burning. Here's Hawaii, and it's still releasing volcanic activity. Um, I'm not seeing as much activity in the Galapagos region during this time period. We still have that um, that volcano going off in southern Mexico, This is over here on the west coast of the United States is from the wildfires. We do have, I don't know what this area, why that popped up red. I don't know what was there that popped up red there. Um, Alaska has been having a lot of earthquake activity. They've got some active volcanoes as well. And I don't, I'm not sure what's going on up here in Canada to release the sulfur dioxide. It could be wildfires up there. I'm not following all of that. We do have on the west coast of South America, we do have some active volcanoes there, and down here in southern Africa. And then Saudi Arabia is high because of the oil production and burning of fossil fuels. Wherever you burn fossil fuels and have industrial civilization, you have high sulfur dioxide levels as well. And mining that can release it. So, and it's still going off down here. You can't see it. I have to move. It's to the left of my mouse. In Antarctica, there's an active volcano. Mount Erebus is always releasing stuff. So that will be chewing up and spitting out the ozone layer as well. So now let's hop over to ozone. This defaults to total column, which reads our good ozone layer. And I'm going to start with the South Pole. South Pole. And we read this in Dobson units when we're looking at total column. And our time frame goes back to Tuesday through today for actual data, and then after that it goes into the forecast period. Now, as this movie loads, we'll look at the chart here. This aqua color is 225 Dobson units. The purple blue color is 200 Dobson units. That's quite thin. They consider 300 as average. Now this equates to millimeters of ozone. Millimeters. So 225 Dobson or 300 Dobson units is 3 millimeters of ozone. That's like total through the all the way through the column. So it's very thin. It's quite thin. And we can see it moves around, and it's in that aqua color through all covering almost the whole Antarctic, and then outside of the Antarctic into the ocean, and then the darker purple, like blue purple, is opening up as well. So the ozone is quite thin over the Antarctic. Now they are still in winter time, and so there's less ozone in the winter time because the good ozone is created as a result of sunlight interacting with oxygen high up in the atmosphere. And so there's no sunlight down there right now. So we do expect it to go thin, but this is quite thin. This is quite thin, thinner than we like. And now I'm going to hop up to the Arctic, and I'm going to show you how the ozone holes are growing in the northern hemisphere as well. We can see it's thinning over here, over here, over here. This is all in the Arctic region. That's that's about 250 DU. It should not be that thin with the sunlight coming in. I'm just thinking it should not be that thin. And this is another reason that the ice can be melting faster, because with a thin ozone layer, it's letting through more ultraviolet radiation. And with the different ultraviolet radiation, it heats things up. And it heats it up from the inside out. And it also increases the wind. The wind speed increases with a lower ozone level. The wind speed increases. We also get more cosmic rays and cosmic debris and cosmic particles. So we just don't know all the stuff we're getting in from outer space. Another good website to watch is spaceweather.com. I might start bringing that into some of the reports, because when we have coronal holes open up facing the Earth, we can have all this debris and matter coming in from the cosmic wind that can be affecting everything as well. Well, this is quite disturbing. We can see this hole moving around in the northern hemisphere from this Chartreuse 275 down to 250 over about half of the northern hemisphere here. Now, it has gotten a little bit thicker, though, than I've seen it at some points. It's getting up to 300 and 325 over the northern hemisphere, so that's good. But it's quite thin over North America. It's in that green 275. So that's from the sulfur dioxide levels. I'm thinking. Now let's hop over to our flat view, the plots view for surface level, I mean column, total column level ozone. And let's see what things look like in your neck of the woods. Here we go with our movie. We can see a huge thinning right around the equator. Now, this area just north of Australia and over to the west of Australia it still has a little bit in the aqua zone, which is 225 DU, but that's not as wide as it was, but it's increased. It's gone up to 250, so that's a little bit better, but that's still quite thin all the way around this mid-level, around where the equator is. And it's that same level up here in this China area. I'm thinking the Himalayas, where it's such high latitude. It's also that level up here in the Arctic like we saw, and also in Alaska and parts of Canada. And then it phases up to 275 for most of the rest of North America, or a lot of it, and then up to 300, but very little over 300. And then down in the southern hemisphere, we see the higher levels of the good ozone. So we have lot of patches, I mean, just holes in the ozone, just moving around. So let's pause this. And now I want to look at surface level ozone. This is what's considered the bad ozone. And this is created as a result of sunlight interacting with pollutants in the atmosphere. And this can be as a result of wildfires. It can be a result of a lot of carbon burning, a lot of gasoline engines going. It can also be as a result of geologic activity. It can be a precursor to earthquakes and volcanoes. So I'm going to zoom in. I'm going to pause this movie and zoom in to North America here. And we're going to get a good look at this surface level ozone. See what's going on here. I'm going to start this movie over again. It has to load. Now this looks like it's up in Canada. Oh wow, look at that. This little landmark is Yellowstone. And so you can think in terms of Yellowstone and over. So this would be the California wildfires. So there's stuff going on up here in Canada. I'm thinking, I'm not sure if that's wildfires. I don't know. If anybody knows, you can put it in the chat room or in the comments when this goes to archive. That's a lot of ozone, though. It keeps pausing to wind up. And then we have this see, and it comes up in the daytime because it's formed when the sunlight interacts. So that's why you see it go away. That's when it's nighttime. And then you'll see it come up and go all the way across the North America, and then it goes down. So if we pause this and go back, we can zone in on some of these areas. Here's the California wildfires and stuff, and then stuff up here. And then we can see surface level ozone coming off the East Coast and coming across over into the ocean. And so these are quite high readings because the cream color even is 70 parts per billion. And the EPA says breathing in 70 parts per billion in a work situation for 8 hours, that if you're in the sensitive group, that's dangerous. So this is, we're in trouble. What can I say? I'm going to let that run for a second and I'm going to pop back over to YouTube and see what's going on. Okay, I'm seeing in the chat room they're saying there are fires in British Columbia. Okay, and fires in Canada. So that's what we're seeing. Fires in Central Africa. There's so many fires, it's just hard to keep up with all of it. It's sad. It's very sad. Okay, so I think that's enough of that. So let's, oh, I'm going to show you one more thing on ozone. I want to go back to the Antarctic and I want to go to surface level. See that? That's bad ozone. Why is it coming up in the Antarctic? I don't understand. I don't know why it would be forming down there at all. There is no sunlight to be interacting with anything unless there's some kind of industry or something that's going on that's creating surface level ozone, or unless it's coming up through the ice sheets. I don't really know, but I'm watching this, and that's what I do. If I see something that looks out of the ordinary, I watch it, and then usually something pops up. You see that? It's moving around. That's surface level. What's that line? Did you see that there's a line where it's not showing up? I don't know if that's part of the computer modeling or what. Watch it when it starts over. Look, see that line? See? What's that? I haven't ever seen that before. That's crazy. So any ideas on that? I have no clue. But that doesn't look right to me. And that's more than last time. That's more of the surface level ozone. Anyway, let's do carbon dioxide and then we'll wrap this up for today. I've been kind of leaving that out because I'm so interested in the sea ice and this other stuff, but I know we need to be looking at carbon dioxide too, because that's the main driver for global warming that originally everybody was watching. Okay, this defaults to total column, and we can see that overall, okay, the lowest we have is in this dark blue in certain regions up in the north at about 400 parts per parts per billion million. That's it's supposed to be parts per, yeah, parts per million. But for most of the world, including the South Pole, it's like over 400, and like once you get into this yellow zone, you're moving on up. Like this brick red, this orangey red is 411. That's 411. Then 412, 13, 14, 15, and above. So let's run this movie, and this is total column. And it's much worse when you go through all the different layers. Look how black it is in the middle of South America. That's from cutting down the trees and the trees dying. As the trees die, they give off more carbon dioxide. So there you have it, folks. Time is short. Time to get your spiritual houses in order. Don't let yourself just get swept away in the tide and being unaware. And I don't mean unaware of what's going on physically. I mean unaware of what's going on inwardly. We have an opportunity to get our spiritual houses in order and to do things at the last minute to tie up relationships and to work on ourselves, to work on self improvement, and so that we can be the highest expression of the divine that we can be, and that we can be aware as we are going on this journey and preparing to leave this planet and leave this existence, and be aware as we're leaving this existence. I mean, it's not like any other journey we've ever been on. I love you guys. I'll see you tomorrow. My name's Margo. My website is margoshealingcorner.com. I'm a hypnotist, holistic life coach, empathic spiritual healer, and I will be starting back doing implant removal work towards the end of September after the sea ice calms down. But until the melt season is over, I'm really busy tracking all of this. So I'm devoting my time to that right now and doing coaching. But towards the end of September, I'll start doing implant removal work again for whoever wants that. So if you want to know when I start doing that again, get signed up on my email mailing list, and I'll send out an email for that. And it'll also be on my website too. So I love you guys. Power to the truth. Till next time, take care. God bless everyone. Get right with God and Jesus. I love you. See you tomorrow. Goodbye.